Hi, everybody. I'm Helen Atkinson, contributing editor at Supply Chain Brain, and I'm delighted to welcome you to this special webinar presentation, Solving the Packaging Problem in E-commerce, Linking Products, Processes, and Automated Technology, presented by Packsize. Today, we're going to evaluate the various sources of waste within a variety of e-commerce order processing scenarios, and we're going to explore how on-demand packaging technologies can help the nation's largest retailers differentiate their operations to achieve their operational and strategic goals. One quick housekeeping note before we get started. At the end of the presentation, we're going to have a question and answer session. Audience members are encouraged to submit questions at any time during the presentation through the Q&A box on the lower left side of your console. Hope you can all see that. Your name and company won't be mentioned if we discuss your question on the live webinar today. I'd like to tell you about the excellent speaker we have today, Adam de la Vega, Director of Solutions Engineering with Packsize. Sorry about that, Adam. He has extensive experience as a supply chain leader and heads the Solutions Engineering function for North America at Packsize International. He holds degrees in industrial engineering and business administration, and prior to joining Packsize, he worked in operational excellence roles within manufacturing, distribution, and healthcare. At Packsize, his team is responsible for partnering with today's forward-thinking manufacturers and e-commerce retailers to develop comprehensive, on-demand packaging solutions that reduce waste, improve productivity, and maximize flow. At the end of Adam's presentation, he'll be referencing a case study from Cardinal Health, which I think we'll all find very interesting. With that, I'm going to turn it over to Adam. Adam, take it away.
Hello to each of you, and thank you, Helen, for the introduction. It's nice to be speaking with each of you today on a topic that's important to me, but also one that I feel will have a profound impact on forward-thinking retailers of the next decade as we meet the challenges of a rapidly changing e-commerce landscape. By way of introduction, I do lead our solution engineering efforts here at Packsize, and my team specializes in the design and implementation of our complex on-demand packaging systems for some of our largest retailers and manufacturers. Over the next 60 minutes, I'd like to share with you my thoughts and observations on how packaging inefficiencies compound the labor challenge in e-commerce, and how our engineers at Packsize can help you and your organization overcome these challenges. I look forward to also answering your questions at the end of the presentation, so please keep those coming. I'm sure many on today's webinar are aware of the changing landscape within retail in the United States. Businesses large and small are retooling their business for digital age and innovating to remain relevant in a competitively, rapidly changing world of e-commerce. Since the recession of 2008 and 2009, retailers have seen a steady and consistent growth in e-commerce, with overall increases of 12 to 15% annually, compared to meager, if any, growth in the brick-and-mortar retail sector. In quarter 2 2019, we finished at $146 billion of overall online spending, which was up 13.3% from quarter 2 2018. In 2016, 12% of all retail sales were completed online. That figure was 13% in 2017 and 14% in 2018. By 2021, we expect 17.5% of all retail will take place online. And we'll also see a shift from predominantly Western commerce or Westernized commerce to more global commerce. With 96% of Americans with access to online shopping, actively engaged in online shopping, and 80% at least monthly, e-commerce retail and the inherent supply chain challenges are a reality for many organizations of all sizes. Over the last 4 years, we've seen employment within warehousing distribution climb from about 779,000 in 2015 to 1.2 million in December 2018, representing an 11% year-over-year increase. Even still, there's demand for another 26% as far as net headcount increase for workers that are currently employed. And that's a trend that we see really no end to. As a result, e-commerce retailers are rapidly turning to increasing wages to retain top employees and keep shifts staffed and buildings operational, while looking toward automation to safeguard their operations from labor shortages as e-commerce retail continues to grow. One of the largest challenges that e-commerce retailers face is balancing their supply chain strategies against labor markets, transportation infrastructure, and real estate costs. With pressures to reduce costs and improve service levels to their customers, it's imperative that retailers have efficient warehouses in close proximity to key markets, which creates distribution hotspots where locations for optimal logistics but incredibly challenging for hiring and retaining critical labor to operate their buildings. While national employment average is 3.8%, many of these distribution hotspots, you see the map on the top right, have unemployment rates that are effectively zero. In many of these locations, the available labor to pick, pack, and ship customer orders is a limiting factor to building throughput and network capacity. And in some cases, retailers are transporting temporary employees from surrounding areas to fill open vacancies. The bottom chart is a little bit small, but you can see that that top blue line is the growth since 2016 by sector. And you can see that the e-commerce and warehousing transportation market is growing at 12%, significantly outpacing healthcare as well as manufacturing and retail jobs. And yet, even with the most modern warehouses today, many of the processes from receiving to shipping are completely manual. Significant advancements are being made in automation, robotics, and artificial intelligence to bring e-commerce in alignment with modern manufacturing, but the volatility, variability, and fluid nature of the e-commerce landscape makes wide-scale automation a challenge, even for the largest retailers. In working with many current and prospective customers, the process of picking, validating, and packing e-commerce orders remain largely manual and one of the largest inhibitors to meeting customer demand. A recent study of 171 top retail executives completed by the Peerless Research Group revealed that lower costs, increasing capacity, and improving order velocity were the top challenges within order fulfillment today. Shortly behind this were the challenges of reducing human error and obtaining enough labor to support fulfillment operations. In parallel to this, respondents also indicated that outside of transportation costs, labor costs were the most rapidly increasing source of expense within their fulfillment operations, above inventory, materials, technology, or any other area. To combat these challenges, many retailers are looking at the next generation type of warehouses, where high-cost activities, typically picking, which require trained and retained operators, mainly picking, are fully automated. Automating these or simplifying pieces with ASRS systems is a viable solution for the dwindling labor supply. However, the downstream bottlenecks of packaging still remain, where most, if not all, orders need to ship in some sort of protected packaging. Many retailers, and until very recently, end-of-line packaging has been seen as a manual process with low-cost, low-skill human labor due to the complexity of the problem and the lack of available technological solutions. In response to labor shortages, we're seeing a shift on the packaging front. Ready-to-ship packaging and automation are hot topics within supply chain strategy. Logistics companies and 3PLs are experiencing the most immediate pressure from increasing e-commerce orders, but consumer packaged goods suppliers are also evaluating how consumer behavior and retail are changing manufacturing directly. E-commerce is causing a significant shift in the traditional retail supply chain, and consumer packaged goods must consider inventory management, individual order picking, smaller shipments, and reducing delivery costs to meet the demands of retailers. This has caused an influx of customers looking to automate and looking to automation integrated machinery to streamline the fulfillment process. In fact, 3 out of 5 brand manufacturers are increasing machine purchases specifically to accommodate e-commerce challenges. Many are focused on the end-of-line or secondary packaging for the most significant cost savings and environmental impact opportunities. These endeavors can help reduce labor, reduce corrugate utilization, and non-recyclable materials, reduce damages, reduce transportation costs, all while improving customer experience and social responsibility. As the labor challenge within fulfillment has grown, we've had a chance to work with retailers of all shapes and sizes in the North American market. In doing so, we've noticed some trends as how orders are received, picked, packed, based upon the different types of products and order profiles that specific retailers are encountering. The diagram on this slide is grouped to approximately show how units per order and orders per day per facility influence the methods of picking, packing, and potential automation that retailers are deploying. Retailers with large orders, or large units per order, and fewer overall SKUs are most commonly discrete picking, either to a tote or to a shipping container. And while this saves sorting and downstream handling, it does require the cost of adding picking modules or replenishment picking to feed those modules, but it allows for quick order velocity through the system to meet critical cut times. In these instances, packing costs are typically lower, but picking efficiencies are also lower, and therefore picking costs are higher. Alternatively, smaller fulfillment operations with larger SKU counts or larger fulfillment operations with significant unit volume tend to batch pick items and reduce the picking cost per unit, then sort those items downstream for final pack-out operation. In these environments, the packing operations become more challenging bottleneck, contributing to a larger portion of the overall variable cost per unit as the picking cost per unit decrease, but the packing cost per unit increase. I introduce these concepts because the on-demand packaging approach and the labor impact of optimized packaging is quite different per scenario, and we'll be diving into these details next. For the sake of today's discussion, and to better compare common practices and processes, it's easiest for us to separate these into what we call box first processes, box last processes, and non-conveyable packing processes. I'll summarize these quickly by talking about the operational drivers and challenges. As a review, box first is typically done with discrete picking, where we have high SLAs or high order velocity priority, a moderate number of SKUs, limited variability in SKUs, and typically the challenges associated with this are paperwork or labeling sortation, carton induction processes and management, and limitation of carton sizes, and oftentimes repack or cartonization exception handling. In contrast, either discrete or batch picking in box last environments tend to focus on variable cost per unit reduction. We often see automation with ASR systems, higher number of SKUs, higher availability in products, which provide some flexibility in how orders are transported, and larger degrees of value-added services or extra processing and packing. The challenges with these types of environments are the labor-intensive processes with item and order validation, paperwork and labeling, extra materials at pack out, mainly due to limited carton sizes and pack, as well as pack station replenishment and operator time and motion during packing. The last process we'll take a look at is kind of a non-convey, which is typically box last. And this is something that we're seeing more often as retailers try to add more SKUs and more variety, especially with household goods, sporting goods, and industrial jam sand type items to their product portfolio. Non-conveyable box last packaging is typically characterized by items that are large, oversized, or overweight. They typically have special needs for storage and transportation. These can be hazardous or fragile items and require some extra processing during packaging. The challenges associated with these types of items are typically the primary packaging isn't suitable for shipment. The items are irregular with shapes and sizes. They can be hazardous or fragile and require extra processing. And limited carton styles and sizes create heavily labor-intensive processes where excess charges for shipping can be incurred, excess materials are used, and the items are cumbersome and challenging to package. Over the next few minutes, we're going to look at kind of some standard processes within each of these types of picking and packing processes and how the standard way of packaging can impact direct labor costs. For the next few moments, I'd like to talk about what's commonly seen in box-first environments from a process, labor, and opportunity perspective. This photo illustrates what's commonly seen in these environments where standard-sized cartons travel to picking modules awaiting order pickers. The slide illustrates a fairly common box-first environment with moderate to high unit and carton volume. In this case, this customer needs to process around 10,000 to 17,000 units each day, resulting in around 4,000 to 8,000 cartons per day. And I'm going to advance to kind of highlight the key points here. On the right side, I've listed the tasks to process paperwork, induct cartons into the picking module, and calculate the per task man-seconds associated with each step. In general, paperwork is printed, sorted, moved to an induction area, and cartons are batched after being labeled. At the end of the picking process, inline void fill and case sealing is common. The overall time per carton process in this example is around 34 seconds. And this is based on what we typically see in a lot of customer environments. This translates into roughly $2.15 in direct labor per carton, assuming personal fatigue and delay and some standard labor costs. Based upon the volume requirements and some productivity losses during peak season due to temporary labor, this example customer would require 6 to 15 FTEs each day to manage induction and end-of-line case sealing. Within this type of environment, we see some big opportunities for labor reduction and improvement due to the limited options of standard cartons, the batching and sorting processes, which add labor and time to the value stream, the compromise between optimizing picking zones and managing materials at production, the excessive void fill used at carton closing at the back end of the process, and significant impact on transportation efficiencies that are created by standard-sized cartons. Later on in today's presentation, we'll review how on-demand packaging can impact these opportunities. When we look at Box Last customers, we're going to spend the next few moments reviewing what's commonly seen in Box Last environments and discussion points. In contrast to Box First environments, packing at the end of the process means very different things for operations teams and the labor costs associated with order processing. This slide illustrates common Box Last environment with moderate to high unit carton volume. You'll notice units per carton are lower and the overall carton volume is higher, resulting in around 8,000 to 12,000 orders per day. On the right side, I've listed the tasks to process totes into orders at the end of the picking process and calculated the per task man seconds associated with each step. In general, totes are inducted, orders and items are picked, or picked and then sorted for batch pick operations. And then typically the tote is conveyed down line to a downstream packing station where the packer completes all QC, paperwork, and packaging tasks. The overall time per carton process in this example is around 67 seconds. And this translates into roughly 43 cents per carton of direct labor once we factor personal fatigue and delay and some standard fully burdened labor costs. Based upon these volume requirements, similar productivity losses during peak season due to temporary labor, this example customer required 20 to 40 FTEs each day, depending upon time of year, at the end of the line for packing and pack station materials management. In these types of scenarios, we see different opportunities. The limited carton options, create excess void and waste during the packing process. There's double handling of items during picking, packing, and sorting. There are time-consuming WMS processes associated with QC and paperwork, as well as incorrect cartonization decisions made. As a result, we see quite often that there's limiting factors within operations due to the tribal knowledge of selecting the right carton, oftentimes when liquid cube is insufficient. As a result, there's significant packer time and motion associated with the packing process and carton selection, as well as replenishing materials and handling void fill. Finally, I'd like to review a final example of common packaging processes and challenges focused on processing of the irregular and non-conveyable products. In contrast to previous examples, these are heavy, cumbersome, and hard to package items, which can incur significant transportation fees, damage rates when improperly packaged, and require significant labor contribution to package correctly. This is a growing pain point for many e-commerce retailers in expanding their product offerings. Let me advance to get the highlights here. This slide illustrates a common non-convey environment with lower unit and carton volume typical of these types of products. This is often in the same warehouse as a Box First or Box Last process, but in a different operational area due to the material handling requirements and the packing requirements of the product. In this case, in this example, the customer must process 1,200 to 2,000 units each day, and oftentimes these are single items. Typically, this volume makes up around 5 to 15% of the overall unit volume for the building. On the right-hand side, I've listed the tasks to process these types of orders. This process is similar to our last example, but everything takes a bit longer as packers struggle to handle large items, travel greater distances, and locate or modify packaging to meet the order's needs. The overall time per carton process in this example is around 149 seconds, which translates into roughly 95 cents per carton in direct labor once PFD is factored. In this example, the customer would need 10 to 20 FTEs, depending upon the time of year, to package product to meet the volume requirements. In this example, we see different opportunities. Most commonly, this is associated with just the fit of the packaging. So, with high irregularity and different nesting and cubing factors of the items, carton sizes, shapes, and designs really aren't optimized for the product. And as a result, we see packers spend significant time modifying packaging or locating packaging. When packaging does fit, excess void fill and protective materials are typically required during packaging. And when we package poorly, items incur damage handling fees and increased transportation costs. I'm going to click forward and play a video from Packsize. And while the video plays, I'll tell you a little bit about our company. With these examples of context, I'd like to introduce and discuss how our hardware, software, and solutions can address the labor squeeze in each area of e-commerce fulfillment. Packsize was founded in 2002 with the goal of bringing smarter packaging for a healthy planet. We're a technology company focused on right-sized packaging, on demand and have pioneered this market in North America. We've got a good track record of high-performing workflows across many industries, including cabinetry, manufacturing, furniture, print, and e-commerce. We have very high reliability standards for our equipment and our solutions, and a trusted support network of over 2,000 systems operated globally. Supported worldwide through our robust technician network and a 24/7 hotline. What you're seeing in this video here is our state-of-the-art demo center in Salt Lake City, as well as our corporate headquarters, and you're seeing a view of our different machine platforms. We also have the largest solar charging network in the state of Utah as an employer with 53 charging stations, and we generate 80% of our power for our headquarters using solar energy. The next thing I'd like to talk about is a little bit of the alignment between Packsize as a company, our hardware and software, and kind of how this aligns with the value savings for our customers. You know, we believe that on-demand packaging is not only socially responsible, but it's the smart and economical way to handle a very challenging packaging problem. And more of our customers are recognizing that smarter packaging makes sense for their operations, their bottom line, and their customers. By implementing ODP, our customers are able to free up space in their buildings, increase throughput, and minimize the cost associated with non-optimized packaging, all while providing their carbon footprint, reducing their carbon footprint, and delighting their customers. For e-commerce customers, ODP can deliver lower costs, less labor, less waste, increased throughput, and a significant competitive advantage for retailers looking to differentiate the retail experience. And in the back half of today's webinar, we're going to dive into how Packsize software and hardware delivers some of these different competitive advantages and value areas that we identify on this slide. Before we do so, I'd like to play this video. And this should have audio accompanying it, but this is a video of our automation roadmap for hardware. Perfect. Hopefully that video came across and the audio could be heard. It gave a great introduction to the variety of hardware and automated solutions that packaging can offer, or that Packsize can offer our customers to solve the packaging problems. What I'd like to talk about now is a little bit more of our automation roadmap and our product portfolio. As illustrated in the video, we're able to offer a comprehensive portfolio of semi-automated and fully automated platforms to bring ODP into our customers' operations. And since 2002, we've had a pretty rapid development cycle in bringing new automation innovation to the space. Starting out on the left is our M1 and EM7 platforms, which are our most flexible solution for manufacturing e-commerce customers with complex packaging needs. These machines here on the left can produce 4 to 8 boxes a minute. They provide some automation, but they really provide the greatest level of flexibility as far as box design, corrugate board grades, and flexible processes. A lot of our customers in non-convey use these machines for overpacking, but these are also a staple within our print verticals, our are cabinetry verticals, are manufacturing verticals, and others where batch production or complex packaging designs need to be created in-house. Moving over to the right next, you see our IQ3 and X4 series machines. These represent our mid-sized fulfillment solutions that provide high-speed, right-sized packaging and compact footprints for box first and box last customers. These are highly flexible machines in their implementation. Our team of solution engineers uses these to design and deliver varying e-commerce solutions where packaging is needed at beginning of line or end of line processes. The production speeds range from 5 per minute to 8 to 10 per minute for these machines, and these machines also have the capability to apply shipping labels directly to the carton, saving some labor and system resource on the WM side. Moving over to the right, we have our next generation of automated equipment, our X7 machine and erected box concept. These provide partial and full automation for box last and box first customers looking to streamline and automate their packing operations with rates that range from 5 to 20 cartons per minute. And that's the applied range. Both of these machines cycle at a much faster rate. So the specification rate for the X7 is 1,200 cartons per hour, and the specification rate for the erected box system is around 600 cartons per hour. But we have applications that vary within that range based upon the customer's requirements. Our team of solution engineers work closely with your operations and engineering teams to identify which machine platforms meet your operational and packaging requirements. And oftentimes, this solution is a unique combination of machinery with customized software integration. As a provider, we can come to you with a recommendation for several different systems that work together to meet all of your packaging needs. Supporting our hardware portfolio is the PackNet family of software products. At the core is PackNet Server, which is our flexible central system that connects to our customers' ERP and WMS systems and allows for customized workflows that optimize how work is completed within the ODP system. Flexibility is kind of the name of the game here, and PackNet has built-in agility to accommodate a wide range of processes and data flows that are built unique to each customer solution. Surrounding PackNet are our family of software products, which include dimensioning modules, cubing modules, cloud-based reporting, and customized packaging software designs, as well as an intuitive remote support UI for our customers. The reliability and uptime are critical in both Packsize customers, and we take pride in the holistic approach we take in designing a software solution and supporting that for our customers. With the technology behind us and an overview of what Packsize is able to provide, I'd like to return to some of our examples. The first example I'd like to take a look at is the box first solution. And I'd like to discuss how Packsize technology can impact the productivity in this example, lowering labor costs and improving throughput through ODP. In a box first or pick-to-box environment, our PackNet Server software and X4 machinery can automate the order prioritization, carton creation, and carton labeling processes. Instead of printing paperwork, batching it, sorting it, staging it, and manually handling paperwork and standardized cartons, our customers can realize total flexibility in order induction without limitation by size, cut time, pick zone, order type, or coordinate branding requirement. What this means, referring to our example, I'll highlight kind of the key areas again, is that the initial steps of induction are eliminated, and with better fitting cartons, the end-of-line void fill and pack-out processes can be expedited as well. Using the same baseline operational requirements, we can cut the total time in carton per half, effectively reducing the cost per carton and overall stacker requirements to support the same order volume, while improving the system responsiveness and simplifying the overall corrugate supply chain. We have quite a few customers that use box first for Packsize, and this is really one of our signatures of what we bring to the marketplace, is the ability to cut labor and optimize induction so that we help the warehouse flow better, run better, and really simplify the corrugate process. When we compare this to the prior state, this solution required 3 to 7 FTEs for off-peak and peak periods compared to 6 to 15. We've essentially taken the direct cost per carton inducted into the system into half. For box last customers, we often recommend deploying a variety of on-demand packaging solutions to best accommodate the customer's order types and item profiles. In this example, we'd recommend an X7 fully automated machine to be used for singles and small multi-unit orders, an X4 partially automated machine to be used for complex multis, and an M1 or EM to be used for larger regular item packaging. Cross-machine platforms, PackNet Cube and PackNet Server can communicate with the customer's WMS and WCS system to translate item dimensions and attributes into packaging requirements, which can then be used to route orders to the best available technology. In our Box Last example, we can significantly reduce the labor required for packing by employing our X7 machine, which is capable of handling up to 1,200 cartons per hour fully automated. In this case, we would redesign the packing line to include order preparation associates who could de-tote orders and prepare them to be fed in the X7 machine. Including these associates as well as machine attendant and a material handler to accommodate the rate of consumption of our machine, we would still reduce the total staffing levels in this process from 23 to 41 in the prior state to 7 to 10 in the future state. And the man-seconds per carton can be reduced from 68 to 23 through the entire process, cutting direct labor costs from 43 cents per unit shipped to 12 cents, all while providing the end customer with a perfect box and the fulfillment center with a simplified value stream for packaging. And finally, for customers with packaging non-conveyable items, our M1 and EM7 series equipment and PackNet Server software can be used to create streamlined processes and flows that create custom-sized cartons in the right design and board grade just in time to dramatically simplify oversized packing. In addition to dramatically reducing packing time and materials, the solution can save significant facility space, damages, and transportation costs while delighting our customers who no longer need to manage cumbersome and oversized packaging. Similar to our previous examples, this slide helps illustrate how packaging time and direct labor costs can be improved by transitioning from standard packaging to customized on-demand packaging for regular items. By implementing ODP, this customer could cut their overall direct labor costs by 30%, reducing peak and off-peak staffing requirements by as much as half. In summary, implementing ODP in each example previously presented would allow us to make a dramatic reduction in the direct labor required per carton shipped. While these results are examples, the baseline data and statistics are representative of the environments we're invited to evaluate and of customers who've implemented on-demand packaging previously. By rethinking packaging processes and unlocking the potential of ODP, retailers can get ahead of the labor challenges created by standardized, non-automated packaging while simplifying supply chains, fulfillment center operations, and reducing their carbon footprint. At Packsize, this is a win on all sides. We're excited to reach out. We're excited to offer each of you the chance to explore these impacts together. Finally, before discussing our case study with Cardinal Health at Home, I wanted to mention how these ODP solutions came to fruition. At Packsize, we take the term partnership very seriously and are honored at the opportunity to develop lasting solutions-based relationships with our customers. The partnership starts with the solutions development process, where a team of engineers and systems integrators work directly with our customers, engineering, operations, and continuous improvement teams to evaluate a potential on-demand packaging project. The process itself is heavily data-intensive as we work to define packaging requirements and operational requirements through initial meetings and on-site full diagnostic sessions. Coming out of this effort, our team will evaluate the best workflow solutions for our customers that include machinery, software, packaging designs, and integrated systems and accessories, and will align the solution to your operational and financial KPIs to review the business case. Once we've got the scope and solution financials set, we'll establish a detailed statement of work and begin working with the customer team to develop implementation, training, and go-live planning to bring ODP to a new customer's operation. A good way to walk through this process is to go through a case study of a customer that's recently implemented ODP. So in closing our session together, we wanted to take a moment to highlight one of our strategic partners who has recently implemented a wide-scale ODP effort within their supply chain. Cardinal Health at Home, a division of Cardinal Health which provides medical supplies directly to their customers, has a network of 9 fulfillment centers nationwide, shipping products to end customers. These fulfillment centers ship 1,500 to 8,500 eligible cartons each day, or at least that's the pack size volume from each building, in a pick-to-box model with standard packaging. And the orders must meet critical customer SLAs to ensure that their customers receive orders as expected. Prior to implementing Packsize, Cardinal Health at Home struggled with maintaining cube utilization versus induction process and flow. Improving flow, operator time and motion, cube efficiency, and cart path or cart density was a constant balancing act for the operations teams. Due to the variability in item shapes and sizes, quantities, standard packaging wasn't working very well. In addition, the management of indirect supplies created multiple challenges, and standard solutions were explored. In the words of Cardinal Health, one carton was designed to ship 180 units of product. The problem was only 18% of our orders were 180 units. We get orders ranging from 30 to 300, and all of these orders went out in the same box, demanding great amounts of void fill. Our goal of a perfect carton became almost impossible. So the top concerns from site leadership and management, you can see this illustrated here in this photo, was the never-changing box inventory, overutilization of void fill, wasted warehouse space, protection and damage of product, forecasting and inventory time that took away from the operations team from running operations. Together, Packsize and Cardinal Health explored how ODP could improve their cube efficiency while alleviating other operational concerns. We defined how PackNet could improve order management, induction, and cart building. And we developed a roadmap, starting with our IQ and EM technology to test the concept in a pilot warehouse in 2016. Based upon the success of the initial pilot project, 7 fulfillment centers were added in 2017, and the final fulfillment center was added in 2018, representing 2 to 4 Packsize systems per fulfillment center. Now, Cardinal Health is implementing our X4 platform to further reduce automation, or to further reduce induction labor, improve automation. And they've partnered with Packsize to develop our next generation of machinery. This slide illustrates the old process on the top with the new process below. As you can see in the prior state, tickets were printed, there was a primary and secondary sort that involved multiple FTEs, and then tickets were manually associated with cartons, and cartons were placed onto carts, typically by carton size. With the Packsize process, we were able to eliminate a lot of that sorting and give total flexibility to induction. So the WM would send orders in waves to PackNet. PackNet would sort the orders by pull time, sensitivity, and tick zone. Packsize machines would produce the cartons with labels associated with each cartons. And then smaller carts could be built with different box sizes based upon order characteristics, profiles, cut times, you name it. The result was that the smart carts allowed Cardinal Health to increase their pick efficiencies. They had less travel distance, more cartons per cart, and improved pick path. In addition, they experienced improved response times to critical orders near cut time because they had better order velocity. A quote from Cardinal Health is, Packsize is the combination of technology and equipment that allows us to package and ship our customers' supplies via dimensionally optimized, cost-effective solution. We no longer need to choose between carrying excess box types and shipping too much air. Now it's possible for us to make a perfect fitting corrugate box exactly when you need it. The business impacts to Cardinal Health were they were able to simplify their induction process, remove human errors from their operation, streamline indirect material management, increase productivity and capacity, improve order velocity and cut time responsiveness, and reduce their overall value stream costs from order to delivery by 2.16%. And now it's time to learn what Packsize can do for your supply chain. We've got a little bit of extra time here in the webinar, but at this time I'd like to open up our webinar for questions from the audience. Helen, do we have any questions from the webinar attendees?
Thank you very much, Adam. That was really, really interesting. So we're at the question and answer portion of our presentation. Once again, I would like to encourage the audience to enter your questions now through the Q&A box on the lower left side of your console. Your name and company won't be mentioned if we discuss your question on the live webinar today. So we do have a couple of questions here, Adam. The first one is, how does the implementation process of your technology work, and how is support or training handled for your equipment?
Sure, great question, Helen. So the implementation process of our technology starts with the diagnostic process. And throughout that process, we define the machine requirements and the operational requirements, the packaging requirements, and how the machines need to be configured. We also work with the local site operation to determine space, layouts, air and power utilities required. And with kind of the engineering behind us, then we look at, how do we plan implementation and operational go live? Oftentimes there's system integration that needs to be done, and so that part of the data architecture is also a component of the project plan. But we work with the site operations to put together the detailed Gantt chart to do the system environment testing, the conference room pilot testing, lab testing, and then we schedule the implementation. So we've got machines arriving on site, our field service team of engineers arriving on site to assemble and configure machines, power machines up, and then run through operator and maintenance training as we get the remainder of the process flow set up. From that period, then there's a period of production support and go-live support of the operators and maintenance personnel at the customer's facility. And then following a successful go-live, we transition into our remote and priority support models governed by our Packsize Care SLAs. So we have regional field service engineers that handle spare parts management, that handle machine preventative maintenance, that handle hotline escalation calls. And we work with our customers to onboard their teams to work our equipment and work in conjunction with the field operations teams to bring it into production.
That's terrific. So it sounds like there's a lot of support that you're able to offer customers there. That's great. So I have another question here, Adam. What percentage of Packsize customers use your technology for box first, box last, and non-convey purposes?
Yeah, that's a really great question. Within the marketplace, we see that around 20% of fulfillment operations is box first, with the balance being box last packaging. I think that within our customer base, we see that mix a little bit different, where about 40 to 50% of our customers are box first in some way, shape, or form, whether it's single piece flow or batch production, and then the other 50% is box last in a variety of applications. And the non-convey would fall into that box last. I think the caveat would be the oversized packaging, where in working with customers, especially customers looking at the right type of automation, we see a lot of customers that want to start with the oversized or non-convey and then move into the mainline packaging. So I think that in terms of the marketplace, we have a lot of customers that are using us for non-convey and working towards mainline solutions. And then within the customer base that we have, box first and box last is split pretty evenly.
Great, so that's really interesting. So a lot of customers are coming in with this sort of harder to solve problems, and then realizing that your technology works for actually all of the picking and packing that they're doing. That's really interesting. Great.
And the big shift we're seeing too, Helen, is also as we're bringing more automation to the marketplace, especially with our X4 and our X7 and our Record Box solutions. We're now seeing customers that have used our technology in oversized, but they're recognizing that there's other Packsize technology through WMS integration and some facility redesign that can significantly alleviate the labor concerns. And so we're seeing the shift to mainline with a lot of our automated equipment.
That's terrific. I've got another question coming in here. Adam, what are the limitations of the fully automated X7 machine? Are there certain products that can't be processed using that?
Yeah, Helen, that's a great question. The X7 machine is designed to handle singles or multi-unit orders that are unitized in some way, shape, or form. So, what we see a lot of customers exploring is either stacking or banding multi-unit orders or bagging those orders. It does have size limitations. So the outbound cube of the item to be packaged can't exceed 24 by 14 by 8. But what we find is that this encompasses about 85% of most e-commerce orders. So I think the biggest limitation really is how much pre-processing can be done upstream of the machine to take maybe a cylindrical item and help it convey, or to take two soft items and bundle those so that they can go through the machine as a unit. But that's also where our solutions engineering team works closely with the customer, their operations team, and our advanced products teams, look at how to develop the upstream flow and the integrated accessories to allow those products to run through the machine.
Right, great. Well, if you're hitting 85% of e-commerce orders typically, then that sounds like it's a pretty well thought out process. That's terrific. Adam, I've got another question here. What would be required for a customer to implement a pick-to-carton system with Packsize?
Yeah, great question. The pick-to-carton solutions really revolve around the accuracy of the data. So we have a lot of customers, for example, that might be new to the WMS system or might not have accurate dimensions and weights. So we start with those customers with a box last measurement type of process. So this could be using a hand scanner or an in-motion Cubiscan type of system to package the end of the process. But what a lot of customers venture onto is the journey to build out their dimensional database. Because having accurate dimensions and weights of your items not only helps you with packaging, but it also helps you with warehouse utilization and cube utilization of your bay locations and other operational factors. So I bring that up because that's kind of the cornerstone of going to a box first model, is the customer must have a WMS or order management system that can provide us dimensional data based upon the order. And this would be the number of units in an order, the size of those units, and ideally the weight of those units, so we can take all of that into account with our cubing software. And that's how we take a customer order and split it up into the correct number of right-sized cartons. So for a lot of customers, that's the largest limitation, is either having a system that can pass us the data or having the data within that system. But we also offer integration and implementation service to help close those gaps so that the customer can move into a fully integrated box first model with Packsize.
That's terrific. Adam, I have a question here. You mentioned a machine that can pack 1,200 boxes per hour. Can you expand on the machine and its capabilities? Tell us a bit more. How many units do you need to ship per day to have it make sense economically?
Perfect. That's a great question. Let me go back to the slide and I'll bring that machine up. So our machine, this question is referring to as our X7 machine, and this is our new automated machine. Can you repeat the question one more time? I know there's a question about a threshold of items.
Yeah, how many units do you need to be shipping a day to have it make sense?
Perfect. Great question. Generally, what we see is that a customer needs to be around 4,000 to 5,000 units, I should say, shippable packages per day, straight line average over the course of the year, to justify the machine. However, one thing that's unique with Packsize, and I probably should have mentioned it earlier in the presentation, but our model that we engage with our customers is different, where while we do offer this machine as a CapEx purchase model, we offer all of our technology under the platform as a service model. And this is where the customer can get in with on-demand packaging at very low startup cost, and then we have a per unit assessment and then very competitive correlated pricing. So while there is a threshold for where this machine makes sense, we're looking at a variety of different customer applications that span a wide range of volume requirements based upon the labor shortage in that area and the operational benefits outside of just direct labor this machine can bring that operation. So if we do have customers that are at that threshold or beneath it, I do encourage them to contact Packsize, and we'll take a look at how we can put together a packaging as a service model with the X7 to meet their volume requirements, because we may be able to move down if the need be. And certainly for customers that are shipping more than that, we have multiple machine options that make sense.
That's terrific. Thank you. That really makes it clear. Adam, I think we're coming up to our last question here, unless anybody wants to pitch another one. Question is, can Packsize integrate with other systems or technologies in my building?
Yeah, and the answer is absolutely. So throughout our history, we've needed to build, and maybe I'll go back to our software slide here.
Great.
One of the very unique positions we're in as a company is that we're really a solutions and service provider. So we're not necessarily in the business of dropping a machine off and delivering it to a customer and allowing them to figure out how to make it work. The onus is on Packsize and our solution engineers, our integration engineers to integrate our system with our customers and make sure that that solution is valuable, the business case proves out, it ramps, and it's adding value, reducing waste in the operation. And because of that, we end up working in a lot of different customer environments with different systems. So we've integrated with Manhattan Scale, Red Prairie, High Jump, as well as homegrown WMS and ERP systems and a variety of others, smaller players in the industry. So we're constantly looking at our software and looking at import, export, data formats and architectures to make our software easier to communicate with outside services. Things like a WMS and a WCS are very common integrations for us. But this is where a lot of the solution engineering takes place with our software integration engineering team, is to talk about within the data scheme of a solution, what messages are sent between which systems at what point, so that we can have either box first or box last orders optimized from a data flow perspective between related and accountable systems.
That's terrific. So I love what you said, that you're not in the business of just dropping a piece of equipment off and getting people to figure out how to integrate it with all their other operations. It sounds like you're very conscious of providing a total solution in a way that's tailored to each customer's unique problems and challenges. So that's fantastic. I think we've come to the end of our questions here. So I want to thank Adam from Packsize for a fantastic presentation on solving the packaging problem in e-commerce. And I also want to thank our audience for listening in and asking some great questions. Any questions that did not get answered during this presentation will be answered offline. If you would like more information, I think we have a contact slide. Oops. We can certainly get that. People can sign in and get some. You can ask more questions at packsize.com, and I know that Adam will be very eager to hear from you. And thank you very much, everybody, for attending. And that brings us to the end of our presentation. Have a great day.
Thank you very much, and thank you all for attending.